like then yeah, Justin, I believe that your expectations must be very high from me on this topic. Like this, when I was approached by Dr. Rajaram about this topic, that is, structural uh, structural this behavior, when there is a there are some effects of from the irregularities from the architectural point of view. It can be plan irregularities or the vertical irregularities. So I was just wondering, like, which codes to follow, because the, like, at the time I was approached with this topic, the IS 1893, the part 1, the revised versions, like in 2025, was not still approved. Like, it is yet to be published. Like, we had the draft, but I was really confused in the beginning, like whether to follow the older code and continue my preparations, or let's say just follow the draft code. Now this, this just I think 15 days, not more than 2 weeks, actually, that code is published. So just, I tried to incorporate some of these things, like some of its salient I mean um, clauses, which I have incorporated over here. In fact, like, I made it in a way, like, understanding that you guys are already following this 2016 version, this, opcodal provisions of IS 1893 part 1. So it is kind of a comparisons between whatever was there in the existing codes and whatever it is revised. Historically speaking, like, from 2002 versions to 2016 versions, in this part of, like, plan and vertical irregularities, there is not much different. I mean, this, these two are kind of similar. Like, there is no drastic change in this, but but in these codal provisions, the recently published one, there are a lot of changes were there. So as a, like, honestly speaking, like, I kind of, you take it as a disclaimer. There's, everything, there's, to cover within these 1 hour 15 minutes, like 75 minutes presentations, it's difficult, but I will try to touch most of the key aspects of these things. So this, if you are, like, this, have any queries, you can stop me in the beginning, like, in the middle, and you can ask me questions. I will try my best to address your queries. Otherwise, you can, at the end, you can ask me, so it's fine with me. I am putting my slide numbers. You can take a note of the slide number, which you can refer later on, so that I can go back and, take a look, actually, what exactly is the queries, and how far I can, address those queries. I hope my slides are getting changed. So yeah, so this is the outline of the presentations. First, I will introduce little bit the introductions. Don't expect anything new from that part. New taxonomy, yeah, that is like, what is there in the new codal provisions and all. I'll just discuss that. Seismic hazard assessment, obviously, that is the major theme of this faculty development program. So I think I have to follow that. Design and analysis provisions, like, again, like, design and analysis provisions itself, usually just when I teach in a class of the at the master's level, it takes almost 4 to 5 lectures to like, solve a problem, not even a problem. Planning irregularities and vertical irregularities, we teach in a separate lecture, a separate, we take separate examples. If we consider both of them together, it will be much more complicated. And this, if we part, and we cannot understand things by part, like, the influence of horizontal irregularities is different from the vertical irregularities. So in that case, this, we follow in this way, like, we first cover plan irregularities, then the vertical irregularities, or the vice versa. So design and analysis provisions, we'll just talk about the provisions only, and after that, effect of plan and vertical irregularities, and in the end, conclusions. So coming to the introductions part. So here, actually, this, while we talk about the this, the plan and vertical irregularities, this, how an industry work. Like, of course, like, I don't have a very first hand experience of an industry, but we are into, like, the kind of the business of proof checking of lot of government and private projects. So in that case, we have seen, like, how things actually in the government level, how things works. In that case, first, this, the architect. So who comes up with a very just beautiful just structures. In those beautiful structures, the what is the issue? I mean, there are a lot of contradictions with the traditional structural engineering phenomena. So which attracts now, just if we simply go with the architectural plan or architectural elevations, then we'll end up coming with a section which will neither be economical nor be serviceable. Why I'm talking about serviceability? Because that is another portion. At the day's end, while you are designing something, it need not to be it's not only need to be stable, or just structure has to be safe in the from the design point of view, and it has to be properly serviceable as well. Serviceable means, in lot of other components are there in the structural engineering, as you know already. So this, I'm simply not going into that detail. So this at the first sentence suggests that plan and vertical irregularities actually cause lot of leads to poor seismic performance and building failures. Let's say about the elevation irregularities. If there is an elevation irregularity, that means the stiffness of the structure is changing a lot from one floor to the other. And we know fundamentally that, in case of, if there is a very low stiffness in a particular story, then there will be very high deflection at the story, which will lead to a good amount of drift. And that drift, will cause lot of seismic demands if we consider it a horizontal load in the context of seismic design. This is equally applicable for the plan design, but in case of plan design, we have still lot of scope. Actually, we can strategically just to correct it, like keeping or retaining the plan kind of as it is, or to there's temper, or there's a change the plan given by the architect in a minimal way, like with a minimum change to the plan of any building or any other structure, we can still go with that, as long as we can introduce strategically some seismic joints in the structure. But seismic joints is relevant, it's possible in case of plan, because if one part of the building in plan is detached from the other part of the building, other than the pounding effect, there is no other connections under seismic load, because all the other loads are vertical and you can do it. But from top to bottom, if we consider the elevations, I just would like to know whether I am visible to all of you. Yes, some of you please confirm, because I'll be using some gesture with my hand that may be also relevant while I'm speaking. Dr.
Yeah,
Rajana,
you are visible. You are visible.
my hand gesture is also visible, right?
Yes, yes, yes.
Okay, great, great. Thank you. Thanks for confirming.
Yeah.
So, this is it. So, just we'll talk about this in detail, like after just when the in the next slides. Then what I was actually my opening remarks was like IS 1893 Part 1 2025, with together with IS 1893 Part 5 provides a refined and clearer definition of these irregularities. The recent code, that is 2025, significantly strengthens the analysis requirements, replacing several simplified provisions of 2016 versions. Since it's a faculty development program, I believe that some of you are already involved in rigorous teaching of or on IS 1893, IS 1390, or structural dynamics, architectural design of structures, these kind of courses. So in that case, if 2022 versions of the code, or 2020 16 version of the code is already familiar to you, then this lectures is kind of a very brief summary, like and highlight what are the recent change which has been done, and what is the reason behind, and what would be their consequences in your final design. Now, this, what it does, the recently revised one codes, that is actually this, whatever simplified codal provisions were there. So, those are replaced with some relatively more complicated equations. Now, this, many a time, we, since our student life, this, we were hearing this, our code should be as simple as possible, such that a simple BTech engineer, a practicing engineer, a diploma practicing engineer can follow that code. But this code, in my personal opinion, this may you may contradict if you have seen the recently revised one. There's a bit complicated in terms of mathematical point of view. Like each of the Besser equations are different. I think Professor Pradeep Kumar in the morning, he has probably has put his like has shared his opinion or his view on this part. So I'm not again going into that part, but still I believe that while preparing this lecture, I was thinking like some of the equations are there which is a bit hard to follow, probably need some kind of guided training on this purpose in this part, I believe. Again, this is my personal opinion, so I mean any speaker or any expert may differ on that part also. um Now, the engineers must now adopt the advanced dynamic analysis methods. Earlier, we have very static equivalent static method, which is simplifying everything together and very fast level analysis. Even a third year BTech students in his who knows about the RCC design can follow that particular part. Then we this model analysis were there, which is a bit advanced and so and so. Then the time history analysis now it's a bit quite clear. So I mean things are complicated, but on ground it will, if you know, then it will be implemented, it can be implemented in a way where you can be more confident on your design. Okay. So this, if the structure is irregular, if there are some heavy installations of non-structural components, of course this revised code is going to give you a mileage on that part where you can be more confident on your design part. Moving to the next slide, what the new taxonomy. Now this architectural element and utilities, just take this name AEU. This has this terminologies. This title has been taken multiple times in the newly revised code.
Kaushikji,
In fact,
slides are not visible. Sorry for the
okay,
interruption.
I'm so sorry. I'm so sorry. I don't know what happened. Just let me reshare it. Your presentation starting. Oh, thanks.
Yeah,
It's
now it is
visible.
visible.
Okay. Just actually, I did not get to know.
Okay, thank you.
Like,
Thank you very much.
just, I mean, you
Yeah.
please block me if there is any
Sorry for the
visual issues
interruption.
and audio, like audio issues at my end. Yeah. Thank you. Okay. So this is
Sure.
architectural element and utilities. So this is a term which comes up multiple times in the code. And as the appendages are the service or the utilities of a building or the structures. Um, that is the imposed load other than the humans or other living beings are walking or running or whatever load is given by them. So rocking, that is one taxonomy. That is an architectural element and utilities that sway back and forth on its support without sliding and toppling during the earthquake shaking. Clear? Because rocking, we all of you know, that is not a very new phenomena. This back and forth on its support, it's kind of a there's a bit very easy chair of the of our old times, and wooden easy chair, how it actually works. So yeah, although in structural engineering we don't deal with this terminology that much, but whoever comes from the geotechnical background, this is a very common name to them in this context of lateral vibrations. And then sliding, sliding, just and architectural elements and utilities that moves sideways on a surface without rocking or toppling. Sliding, as the name suggests, this is not a very big deal. Then the toppling, again, this that is an architectural element and element that overturns and fall sideways like this, okay, on the one side on a surface without rocking and sliding. So these are some kind of shaking modes, I would say. So shaking gestures of a shaking behavior that is structure depicts under an earthquake shaking. Okay, so it can be either rocking or sliding. If there is no two, then it's a toppling. And you understand the toppling is kind of the failure. Rocking and sliding is still, is a part of an analysis. Terminology comparability will just note this, these things. The tick. The tick means this is there, but not defined properly. This is that sign I am going to use with it. This is a sign I am going to use with it. Okay. Um, just hold on, please. Yeah. Uh, this is the sign. That is a I'm like, just, I'm going to use which is present but not defined in detail. Then the star I'm going to use in the next slides, please keep this in mind, because rather writing in a remarks newly introduced, it is already paid, it is not defined, and so and so. That is newly introduced, that means added. We call it addendum, corrigendum, we know, right? This is kind of an addendum which was not at all present there, which was absent in the earlier version, but it is present now. There is, which is very much formally defined and which is very close form now. Like, you can take the name, and you can consider strongly in the analysis. Then the last thing is the most important one, is the modified and the expanded definition. As I told you, the recently revised codes, that is 2025 versions, November versions, became a bit complicated. I mean, I would not say ki it's very hard to follow, but it is not as simplified as its earlier versions, that is 1993, 2002, or 2016 versions. Now, whatever is already present, that is quite obvious. Whatever you know, that existing knowledge will continue. Then the next thing is star, that is newly introduced. Something new you need to know to perform the seismic analysis. And the last one, that is, it's a hollow triangle. I just use this symbol to depict, to show to you guys. That is modified and the expanded version, and there is the problem. What I'm saying, like, the way an industry works, they have their, very established, uh, Excel sheets, or their, spreadsheet, their worksheets, their work command window, whatever they are having. So they need some kind of modifications. If I am using my class notes, I probably need to modify certain this, calculations following these modified versions, and that is the most difficult part, I believe, because in 2002 and 2016 versions, whatever changes were there, if it is a newly introduced, that was very easy for the engineers to grasp, to assimilate. But if there is a modifications, you have your existing knowledge, you have to change that. So that is the most difficult part, this, which I found, this, to convince the practicing engineers, yeah, this is no longer in practice, you have to follow this. Because to replace a existing knowledge, it's a bit challenging in comparison to learn something new. Anyway, that's why this hollow triangle, wherever I put over there in the next slides, please do pay more attention to that part, and I will try my best to give a, in more emphasis on that part. Again, honestly speaking, in all these expanded and modified versions, I am still exploring. I am expecting some commentary from that part, from the proposed, from the team members, in the form of commentary. So this, whatever I could unfold by going through the codal provisions, I'll only share that part. I may not be able to address all such concerns, which is the modified and why it has been done. So I was not a part of drafting these codal provisions. So yeah, I mean, it will take some time for me to learn. So this, it is just 2 weeks. It takes usually a bit of time. Anyway, that's why probably Dr. Rajaram has chosen this time form. There's, where he can be the one of the very fast people, fast one, like, where this kind of information is now being shared in the form of a faculty development program. You, Dr. Rajaram, isn't it? Anyway, coming to the terminologies in detail, I have also kept the 2002 alongside. So bare frame and bare structures, what is bare frame. So it was the 2002 versions, it was kind of silent. In 2016 versions, concept was there in the modeling, but it was more often, just, it depended more on the understanding of a designer, or a designing firm. I mean, some kind of liberty were given, so just, was given to the designer as well, concept was there, they have explained something, they spent couple of sentences on that, but there are no closed form, there is no closed form concepts or closed form thoughts delivered in the 2016 versions. But after 9 years, couple of weeks back, as per the codal provisions, it is now very much formally defined. Just note that since I'm just telling it's a formally defined, that means it's a modified one. I used a asterisk. I used a very, a star over here. Okay, the black star. A white triangle would be there. There's no wherever there is a modifications. So what is the take away message from here? It gives a formal definitions, building and structures without architectural elements and utilities. This is given. Okay. Now coming to the infill frame or infill panels. Infill panels are can be any kind of brick masonry, stone masonry, kind of structures. That is bare frame means only beams and columns, that kind of arrangements. It can be single and multiple form, like a typical portal frame we actually learned from in our structural analysis course. Infill frames, yeah, this is a frame where from actually this, which is filled with brick or stone masonry or something else. So it was kind of, because that play a very important role in lateral loading. If I consider the vertical irregularities, if you see a multi-story shopping mall, one story may have some infill, one story may not have. Now this, we know that an infill wall can increase the stiffness of a bare wall by, let's say, 10 to 20 times of whatever it was there in case of a bare frame, because the strut actions of that this infill wall, so which gives significant stiffness. So in that case, you understand how important that would be in terms of vertical irregularities. Anyway, that's why it was already earlier version, it was there, it is still there. So and the modeling guidance was already present in the 2016 version, so there is not much change. But still I thought this is very relevant in my which is aligned with the theme of my presentation, so I just kept it. Yeah, so one more thing I need to mention over here, that is there are various tables. mm, So that is mass irregularities. Um, in table 5, you'll get to see about the mass irregularities. The threshold earlier, it was already there, but thresholds actually kept unchanged, so there is no change. So that is 200% mass jump that was already there in the table 5. So if you have the earlier recently version, this revised version of the course, you can simply check during the presentations or after the presentations. Anyway, this sessions is being recorded. I think the slides will also be shared. Rajaram, the slide will be also be shared, right? Dr.
Yeah,
Rajaram, are you there?
yeah. Right now we don't have any plan to share the document, so later we'll decide.
Oh, okay, okay, fine then. So at least the sessions, yeah, just anyway, so you can take a note of it, the table, whatever table number was this there and all, as it kind of a class note. You are a faculty although, but anyway, this again, soft story and the extreme soft story effect. One of my favorite chapter actually. Soft story, you all of you know, right? In the very preamble, this, let's say, very second or third slide, there are a list of terminologies which is there since the 2002 versions. I believe this is also there in the recently revised versions as well. So this, it retains the concept whatever was introduced in 2002, and the of course I'm not aware of the 1993 versions, because I did not become engineer before 2020, before 2002. So I'm not very familiar with the 1993 versions, but I've seen that 2002 versions had these things. Weak story, yeah, again this is also was there, this is there. Now soft story weak story is very much related to your vertical irregularities. Then comes with torsional irregularity. Torsional irregularity, which would be available in table 4. This, again, it is same. You know it probably that, we have a center of mass and the center of stiffness, and there is something called design accidental eccentricity, and there is something called design load. And based on that, this, a weak floor attracts more, there's force leading to high seismic demand in any structure. Torsion is very dangerous actually. We follow a thumb rule, although it's not mentioned in the codal provisions. When we check that, this any when we proof check any building or any other structures, we try to check two principal directions of vibrations are whether perpendicular to each other, or and also we check they are in the first very first two modes, there shouldn't be any torsional mode. If there is any torsional mode, then we need to revise our design in a way so that we don't get our torsional mode in the very first and very second mode. In third mode onwards, you still can have the torsional mode, we usually allow it. And considering the fact that the mass participation factor would not be very much significant on that part. Reactants corner, it was there. Diaphragm discontinuity, it has been there. But these are the various terminology. I just simply wanted to make you familiar with the terminologies which are very well defined in any standard textbook and also in the codes. So I don't think I need to explain anything on that part in these parts. So on these terminologies, then is out of plane offsets, it was already there, it is there. Non-parallel systems, it was there, it is still there. Then coming to this vertical geometrical irregularities, it remains same. There is vertical geometrical irregularities, the threshold has been defined as 150%, 1.5 times, it remains unchanged. Then the in plane discontinuity, it is also remain unchanged. Then this mass irregularities, that is that is kept as same. Since the name of the theme of the workshop is some codal interpretations, considering the recently revised codes, I thought ki just let me make you familiar with different terminologies relevant to the vertical irregularities and the horizontal irregularities. So yeah, done. Next is ground motion terminologies. That is yeah, so mind this star actually. So uniform hazard response spectrum. Yeah, that is something very new. Again, it's like next semester's as a part of our curriculum, we have earthquake resistant design of structures in the next semesters. So we are going to have a bit of hard time in decoding the code in the very next semester, which is just even not a month away actually for us being a teacher. Anyway, so uniform hazard response spectrum, which was already there in various standards textbook and books on earthquake resistant design of structures or advanced RCC design. And it can be in the form of advanced this even like in a structural dynamics textbook. So this it was not a very new terminology for us to calculate or to this analysis to analyze. However, this code was never very vocal on that part, or we had been following that as a part of our calculations, but code was never vocal on that part. So for the first time they have acknowledged and introduced uniform hazard response spectrum. That is very important. And again, I'm saying like don't ask me what are they, like what is uniform laser spectrum and how this is calculated. Again, just you are encouraged, you are requested to learn the terminologies by your own. It is already defined in the codes or any standard textbook. Then you say rod dpp, rod d50, rod d100. So this kind of terminologies has been used to consider the rotation dependent spectrum analysis. As far as the last codal provision is concerned, so we were only considering about the translatory movement, x directions, y direction, and z direction, ex, eqx, eqy, eqz. While considering the x directions, we'll consider the 30% in y and 30% is z, and we consider the various load combinations where the dead load and live load are also present. This is for the very first time. This they have introduced the rotation independent response spectrum. So these are different terminologies which you just simply take a note of, and you can consult with the code This is something probably you would not get directly in a very basic book of architecture and design, but the book by Villavade and all, and they have already discussed the rotational components and all. So yeah, in fact, during my PhD times at IIT Kanpur, one of my colleague was working on this, rotational component of earthquake, who is presently faculty at IIT Roorkee now. Anyway, so yeah, so this that actually is, yeah, has given some importance on while designing structures. Now this rotational component, how it is relevant to me, how it is relevant to this lecture where I'm considering the vertical and ordinary irregularities. This is because, like, we have this rotation is related to mostly on the torsion, like related, relevant to torsion. Torsion comes from the design eccentricity, extended eccentricity, the distance between the center of mass and the center of stiffness, and lot of other irregularities, mostly the plan irregularities actually. So it is good that they have not only introduced the concept of, or defined or extended or expanded the concept of irregularities in detail. They also have given some remedy following some recent research outputs. So that is something, like, the best part of these codal provisions. Coming to the next, conditional mean spectrum. Yeah, that is again very new. Conditional mean spectrum. Earlier we had what? We had a site specific response spectrum at max. So of course, site specific is another conditional response spectrum, but we used to do it by ourselves, But for us, we had a very blanket, codal thing. Like, we have to follow these codal provisions. And in 2016 versions, they came up with 2, 3 response spectrum, but those were also not sufficient and looks like quite same, and not incorporating various parameters affecting our seismic design outputs. So this conditional mean spectrum is now here to help you to come up with some kind of advanced ground motion selections. We need not to blindly depend on this simple, means response spectrum, which was there already in the earlier version of the codal provisions. Next is, once you are done with this, now for matching we need to do something, whether whatever you have come up with, whether this is correct or not. For that, we have target response spectrum. Yeah, target spectrum it's called, as per the code. Target response spectrum. It's actually was, so these kind of terminologies or the analyses where there is no trace of such things in the earlier versions, but in the new versions they have already included that. That is the new in the 2025 record selections procedures, and it is, it will be used in future. But I believe that it will take some time again, like, to assimilate that part. In fact, I remember, like, during the beginning of my career at IT Partner in 2015, we also have conducted one workshop in 2017, I believe. So, we really had a very hard time, although there was not very significant changes made in the 2016 versions in comparison to 2002 version. But still, like, we really had a hard time to convince the industry to follow such codal provisions. In fact, the another struggle is the standard software like stats and all, which is very popular in the industry. They have to come up with, this new design, just calculations. Yeah, they have to introduce all these changes into their systems, so that that directly to IS 193 part 1 2025 versions can be called, and the design can be performed. But then that is the reason actually it will take some time. But if in the beginning, within 2 weeks of the course, if you can get to learn all these things, if you can just come up with your design, and you will get certain level of advantage, which is called fast mover advantage. So in your teaching, in your industry practices, or whatever it be, in your field, in your career. Anyway, just next is spectral compatible ground motion. This spectrally compatible ground motions. Now this is a new terminology, but I would not say this was not there. So of course, like, I mean, in the research we had been considering that. But yeah, this is something new in the name of a terminology in the code. And I believe that this spectrally compatible ground motions, that would may not change much of your outcome but I'm not sure again. I did not use the total provisions yet in my design so far. Coming to the few more terminology, that is, yeah, just, you may think that, this, sorry, the professor is teaching so many terminologies. I'm only focusing on those terminologies which are new, and within 1 hour, like, I would not be able to do any kind of detailed description on that part, 1 hour 15 minutes, or let's say 1 hour 30 minutes. This, that's why I'm just simply giving you, just motivating you, what are they, and why this has been introduced, and so and so. Okay, so please excuse me in this part. Mm, in the modal analysis, you had the modal analysis earlier as well, but now a generalized coordinate and generalized concept of generalized mass have been introduced, and that has to be incorporated while you are doing the modal analysis. ये पहले भी it was there in the beginning, this modal analysis, but yeah, this is, sorry, introduced. Next is, missing mass corrections. Okay, yeah, missing mass corrections was there. 2020, 2002, I don't remember, although, but I don't think it was there. But 2016 versions, they talked about that. But it was very, not, it was not at all transparent, or very clear how to use that. Indeed, I knew whether you need to use that. Now 2025 version is very clear about imposing these corrections factor, considering the missing mass one. Okay, so just, earlier you had the option. In fact, many a time I also ignored that clause in the 2016 versions while designing, while teaching, while proof checking. But now you don't have the scope actually. If there is it is missing mass corrections factor is needed, you have to do it. That is a kind of a impositions. Now it is no more given as an optional view or optional point to consider, to incorporate. Modal participation factor, all of like, in our structural dynamics, it is there. We can directly come up with, usually we know that, if 2 3 modal mass is, more than 90%, then that 2 3 mode we need to only use. These kind of codal provisions are already there. For the closed mode, there are certain things mentioned. The fast modal participation has to be more than 70 to 80%. So those things were roughly there. And even just in the 2002 versions, I've seen, even during my student life we learned. In fact, I've seen the industry is widely using this part, mass participation factor. But now they have made it very clear. So this, I have this, earlier it was there, this is there. The practice was to follow this mass participation factor is not very tough. So it was being followed, and it will be followed as a mandatory clauses now on. Okay, now onwards. Design basis earthquake. Like पहले भी था, it was earlier there, it is there, it will be there. Maximum considered earthquake. It is there, it will be there, it was already there. Anyway, then as I told you, architectural element and utilities, that is the very basic terminologies I need to use multiple times in this context. So AEU, comprising of 3 major vowel except I and O. So they have given a different classifications. What is architectural element and utilities? Earlier, this terminology was not at all there in the code. So now they have introduced this code, they have defined it, and their utilization is also very much defined. Next is rocking. Rocking is, this is the newly defined 2025 versions. And this, next is sliding. That is, earlier it was not there, but it is there. I have already discussed that. Toppling AU, it was again not there, this is there. So these are the 4 very newly introduced terminologies, along with their formal definitions and user guidance, which you cannot bypass while designing a in our language, and yield shape structure. Without this, any of your session, like today, even I'm not sure the next presentations, even in the since morning, Professor Pradeep Kumar, Professor Raghukant, this, I mean, without this, any presentations, there's any seminar in this FDP would be kind of not complete, I would say. So I mean, do I need to mention anything on that part, because this is not anyway relevant to my actual theme over in this context. But just just I wanted to show you how differently things are changed. One important part to say, like, just see uh, this Delhi and Jaipur is taken into in the zone 4, and that too very, because Delhi and Jaipur used to be in a two different, what to say, if you see, Jaipur used to be at zone 2, whereas Delhi used to be at zone 4. Now just see, I'm so sorry, yeah, I'm so sorry. Yeah, but the Delhi and Jaipur is in the same zone 4. So Jaipur, whoever is coming from, or any, if you have this is your area of interest. So there are certain, mm, zone which got promoted not by one grade, but by more than two grades sometime. So earlier you can see this, the part of this, this Darjeeling and Alipurduar used to be in zone 4. So now everything blanket, it was kept in very much zone, zone 6. So there is a promotions of zone 4 to zone 6 in various context. So yeah, so these are certain things. And of course, like, in this, if you see the map, I'm not sure, seismic hazard analysis, they told that there it is a probably seismic hazard. Just note that it doesn't look like that, this actually, they bend that line, this, in a way they can cover the Delhi and Jaipur together. How many of you feel so? Isn't it? I mean, there are certain level of, all regions are not always technical. My professors used to say at IT Roorkee that, see, there are certain regions which are political as well. So they always wanted to put this Delhi and NCR in the very highly seismic or highly risk zone actually. So anyway, so that is, again, as I told you, that is not aligned with my theme of my presentations. I just wanted to show you this. Although my previous speakers and my future, this, the speakers will be succeeding me today or next day, and they will again probably will come up with on this slide to discuss more on this part. But again, this is not my part to speak on. Let me move to the next part, that is one of my favorite, that is called seismic hazard assessment. By seismic hazard assessment is kind of, this is what these things we always do actually. So in these 7 revisions, so they have introduced a couple of zones, that is, zone 6 was not at all earlier there. They have introduced zone 6, and for the structural safety, they have introduced new provisions in the considering seismic hazard assessments, and they have updated the criteria based on the probabilistic hazard assessment. Earlier they were using a very different approach. If you see that disclaimer in the beginning or in the declarations in the back, they will see that, this probabilistic seismic assessment has been used, hazard assessment has been used to come up with this zonation map. Zonation map revisions, probabilistic earthquake hazard analysis we need to do. Earlier we are not doing while following the code, but as a part of an analysis or research, we had been, this is not a very new term to us, but anyway, so yeah, this is being nowadays done. New highest risk zone has been introduced, that is zone 6, that is fine. And Himalayan belt reclassifications, this has been done. Listen, if you see this earlier code, actually, in that case, green was there, and in between there are some orange pick, or the saffron, this pick was like the pocket were there. Entire northeast was also considered as zone 5, the highest one. But now this, if you see, the entire Himalayan is kept under a seismic zone there as an outcome of the probabilistic hazard assessment. Considering the Himalayan region, there is a threat, as you know, probably, that a very devastating earthquake is going to come up in near future, as per the paleoseismologist. I mean, the seismologist or the geologist who deals with seismic tectonic tectonic plate movement and so and so. In fact, like this, when I'm saying in a very recent future, that means for a paleoseismologist, for a paleoseismologist, just recent future means it's 50 years, 100 years, like that. So yeah, if you are unlucky enough, lifetime, we can get to see that as well. Let us So it can be looked as a preparation of such things, as that any new building or any new structures going to come up in this region, should be considered as very highly seismically vulnerable one. In fact, if you see this, all in major cities are coming into this seismic zone, highly seismic zone. Let it be Shimla, let it be Dehradun, Roorkee, Chandigarh, everything is now coming under this region. Earlier, this was not the case. We had certain level of, you know, food kind of, we are using zone 4 at the time. Anyway, moving to the next. Zone boundaries, as I was telling, it has been adopted as a highlight zone if there is any boundary of the city. Return periods. Return periods actually just specifies the design horizontal accelerations coefficients for each earthquake zone corresponding to different return periods. Zone 2 corresponds to now 2, 4, 7, 5 years of return period. We know we follow a Poisson distribution in this context. So again, I'm not for going to 10% probability of accidents, 2% probability of accidents, and so on. So this concept you already know in 50 years. So that means 275, 2475. If there is a 2% probability of accidents, 10% probability of accidents, then it will be 475 years return period actually. Following Poisson's distributions. Code structures, this is the newly devised one actually are divided into different segments. Specific building provisions are also given in detail in the newly revised standards. Non-structural safety components are also introduced. The major focus were given in the non-structural component. Let it be facades, let it be false ceiling, let it be parapet wall, let it be isolation wall, separation wall, water tank. So special emphasis had been given into this. So yeah, so this can be has to be considered and anchored if the weight of all such non-structural components exceeds 1% of the entire floor load. I'm still confused the floor load whether includes the dead load of the floor or not. Probably not, but this is still not clear to me, honestly speaking. That's why I need to explore it more. So I cannot give clarity on the matter. It is excluding the dead load of the floor or the including of the dead load of the floor. Anyway, that's why I have highlighted this part in blue color, because I need to explore this more. As I told you, I really did not get much time to, it's not my fault again, because the code only got revised a couple of weeks back. So I'm still waiting for some more observations from some other experts as well. Probably when I'll be presenting next time in after a couple of months, I will try to make myself enriched enough to address all such concerns, all such, to connect all such missing links which I am still struggling to find out, with good explanations, of course. Yeah. Now it's coming to the near fault provisions. Yeah. So there are two things. One is far field earthquake and the this near fault provisions. Because if the structure is in the vicinity or the close to any fault line, let it be intraplate or interplate or interplate. So the velocity demand, the seismic demand of the structures spikes actually. So velocity demand has lot to do with your seismic demand actually. So so that's why the near fault earthquake structures or the far field structures, the seismic demand between these two is very different. Their nature of vibrations, their nature of dynamics is very different. So earlier we are considering typically it's a far field earthquake. So now these near fault provisions are made very clear to it. So any structures within 20 to 30 kilometer radius of any active fault line has to be considered a near fault pulse motion. I told there is a spike in the demands. That means it's formally called near fault pulse motion, which are highly I told you already anyway. So in case of major earthquake, okay. So this is something which is newly introduced to this code. But I remember few of my fellow lab mates who are working or researching on this topic or near fault or far field earthquake 10 years back. So happy to see that some of their outcomes is already acknowledged by the committee, and it got some space into our recently revised codes. Soil considerations. So in case of soil considerations, see, I'm a structural engineer, although work on soil structure interactions. As I see the panel already, Dr. Mohanty will be there from IIT BHU to talk on the liquefaction part. Liquefaction was already anyway introduced in this part, in this structure, like in the earlier version 2016 course. But believe me, that was very hazy actually. There's lot of equations, and even the units are very different. Something foot per second square, just meter square for sorry, pound per feet square, and kilometer per meter square, all the units. There are a lot of confusions actually. So I remember when I was teaching this for the first time, as a part of my course, software system design of structures, I think in 2022, sometime during the lockdown. So I also felt these hardships actually while teaching that part. Now I think I believe that these new codal provisions had made it more detailed. As I told you, these codal provisions is a bit complicated to follow than the earlier versions, because this is no more a very simplified one, unless otherwise you don't have an expertise on structural dynamics. Some of the provisions, some of the clauses, they are really hard to follow. I mean, again, my opinion, but I believe that will be the opinion of the others as well. So before following this code, if you have a good understanding of what is soil flexibility, what is its contributions in the structural vibrations, and what is liquefaction phenomena, and what all these and the technical terminologies associated with that, if you are familiar with them, then of course you would not face much hard time to follow this codal provisions. Anyway, so but anyway, just soil condition was anyway there. In the dynamic analysis, yeah, now this time history analysis now is strengthened. Now this is something which actually I had been waiting for a long time, dynamic analysis. Because if I change the plan and vertical irregularities, because then if you follow the equivalent static analysis, it is not going to help at all. If you consider modal analysis, to an extent, because as long as at that time the mass participation factor was clear, so modal analysis was good, giving a very good results, to an extent conservative also. But our purpose is served. But while talking about the time history analysis, 2002 versions was kind of silent. 2016 versions was vocal. It talked about that, but very limited talk, and it depends on, it has to, the time history analysis should be performed, and they left it to the designer. Now this in case of any litigations and all, I'm not sure how this is going to be addressed, but I'm happy to see that they are now very clear with the various time history analysis. There's how this has to be done for different zones. In fact, there's happy to see that for different zones they came up with a different representative ground motions to perform the time history analysis. That is the probably the best part of these codal provisions. This is not at all complicated, because time history analysis is the part of dynamic analysis. Industry was kind of avoiding that. Many a time I have seen a response after the model analysis, please, for the some nonlinear actions, if we are just if we comment on this part, time history analysis need to be performed, then that's right away the response from the designer would have been sir, this is not mandatory as per the clause. Now I'm happy that we can now force the designer, the structural designer, to come up with this time history analysis. And of course, time history analysis is very close from, and the actual behavior of the structures, of course, that can be captured, but the kind of we can move nearer to that. Anyway, Coming to the story depth limits, the permissible limits now updated. Now, earlier it was whatever it be, the are now specified based on the building's locations in a particular earthquake zone. So earlier it was very blanket one. Now the story drift they have made. Story drift means the relative movement of the one story of the other. This is very important because this is where sub story actually plays a very crucial role actually. So that is why the stop story is important, and a sub story effect, to understand the sub story effect in a given structure is important. And we and any strategic locations, this we this shear wall can be introduced, especially when the horizontal irregularities are massive as a consequence of architectural ill-shape architectural layout. Story depth, I would not say much. So it was very blanket earlier. Now for every zone, the limit has been defined. Maximum elastic value of the elastic analysis, it was given 0.4% of the story height can be given as the minimum specific design lateral force. Now it is very much zone dependent, and it has been made more conservative, more strict actually. Because I mean, if you are more strict on this, of the story depth part, now you understand that your as to meet that seismic demand, your sections is going to be much higher. Your structure would have would experience more inelastic demand, more ductile demand. So there are to compensate that, you may come up with a higher sections, higher reinforcement, ending a heavy load on the economical point of view. In fact, that is probably one of the reason. um, my yeah my slides are visible, Dr. Rajaram?
Yes, sir, it is visible.
Yes, it
Okay,
is
thank you.
visible.
Okay, thank you, thank you. Okay, so this, I just wanted to check. Yeah, so that's, I mean, this is it. Like, it is now zone dependent, so it will give some pressure on the economy. So that is one of the reason. So I'm not sure whether it can be on the record. So for I heard that for the industry, lot of pressure was there to make it more simple, or a less stricter. But anyway, so I'm happy to see that our voice is were counted, okay, considered. Anyway, coming to the applicability point of view, this 2016 versions was generally applied to all regular structures. However, here in in this part, non-structural component safety has been focused on, okay, and made strict limit on the irregularities and the specific non-structural components. In fact, sometimes any structures may not be that much vulnerable. Your structure may sound and safe, but irregular installations of water tank, your heavy machineries, your mumty room, because those are heavy machineries, right? Water tank is let's say if it is a 1,000 gallon, sorry, let's say 1,000 liter of water tank, it's a very heavy load that on top. You understand how heavy load that would be, and how what kind of eccentricity it can create during a seismic event. Even facade may apparently look like a very lighter structures, but in heavy machineries like mumty room on top of a lift well, even just some heavy machinery installations, let's say AC control units, these and that. So all the things are the non-structural components. So a lot of architectural things are actually considered into the account. Now I think, again, I'm saying I'm happy that at least we can show to our architects, see, these are the provisions we need to follow, and we cannot do anything about that part. But otherwise, this the fight between the structural and the architectural engineer was inevitable, but we were kind of helpless, because they, because of their beautiful presentations, beautiful because of their this beautiful come up, like in terms of the structures, the clients were happy with them, but we structural engineer has to convince multiple times to the client that this is not safe, this is safe, and so and so, and we are in struggle. But now I'm happy that a lot of architectural concerns from the structural engineer were incorporated, are incorporated into the system for considerations. So yeah, that is a very major achievement तो नहीं बोलूंगा, that's no, I'm not say. There is a very major change in this course which I'm happy to see with in like happy to see. Design method basis. In the response spectrum method, we actually not been using much of the partial load factor, which is one, that there is nothing, but the limits derived from the probabilistic hazard assessments has been introduced. Some coefficient has been proposed for different return period of an earthquake. So this has been done. So design methods also got changed. Yeah. This is something which I are actually talking about. Like, you have a center of mass. CM means center of mass. CS means center of stiffness. We call also center of resistance, like CR in the codal provisions and some of the books as well. So your inertia for force during a seismic event or any lateral load acts as the acts through the center of mass, because it's mx double dot. So wherever there is a mass, the x double dot will act on that locations as a center of mass. However, structure, it has the static load resistance capacity, and we know that the source of that resistance comes from the stiffness of the structures, because during our BTEC time, it's kind of establishing the relation between stiffness and the force always to come up with the deflection. That's it. In this case also, so center of stiffness is the center of resistance of the structures. If the load is acting through the center of mass, if the resistance is acting in the center of stiffness, then this typical rotations would be somewhere over there in between. So what will happen? In this case, so there will be some torsional force, torsional moments, and because of the torsional moments, the weaker sections, because of its high rotations, would end up having high seismic demand, ending up high seismic loads in each of the structural components, and based on that, your seismic demand is going to increase a lot. This is a T-type structures, how it is working, and this is already given in that codal provision, so I'm not going into that detail on this part. But here, because of these two and vibrations, the different component will vibrate in a different manner, ending up some hot spot in this failure in some hot spot. Okay, so where the failure would be, structure will be more vulnerable. Additional steps developed in building having planned irregularities during earthquake. Yeah, so some stress concentration. If there is a L-shape one, then because of the two and fro vibrations, the corner will have more stress concentration as like a sections, as you know already. In case of Z-type structures, so here also in case of C-type structures, this is the mode of vibrations, and there will be some additional stress concentrations, resulting in seismic demand at its corners. It's now all about the horizontal irregularities. Now talking about the vertical irregularities. If there is a step configurations, in case of step configurations, you can see there is if this is something like that, then this top portion is more kind of more unsupported, bottom course is more stable. So in that case, during any seismic event, this part would end up being a more vulnerable one towards earthquake, because of its high amplitude of vibrations, leading to more inertia and ending up leading to very high seismic demand. The step configurations is another source of irregularities which we'll get to see in because due to the beautifications purpose in some good hotels, also like in something nowadays in the residential colonies as well. But these type of structures are quite common in mountain areas where the ground is quite soapy. But to address that, I think you have this third part where there is a slopy ground. There, these are the different setback configurations are there, which will end up having high seismic demand. Vertical irregularities were building due to variations of the story stiffness. Yeah, this is something quite common, which is not very new. It was there in 2002 versions as well during our student life. So we had been learning these things. The story stiffness cannot be less than 80% of its neighboring codal, neighboring floats adjacent to that floats. So yeah, this is something which we need to consider, considering the vertical irregularities. This is one more irregularities. Um, in this year, in this, then because of the story height, as I told, like, some of bigger, based on the purpose, some of the story height may increase a lot. Like top story is actually is the house, I mean the roof is the roof house is the house for the mountain room, which is quite heavy, being a mechanical engine. And sometimes the TG sets kind of things are mounted on top of a building. Sometimes it can be in the name of water tank or some other heavy installations, maybe the AC unit of the central HVAC system. So top floors are typically are made heavy in most of the residential and the commercial houses, commercial buildings. So this, for that part, actually all these non-structural components are taken into considerations in the recently revised code, but these are some major concerns. On top of that, some intermediate story hand can also story these things, the mass can also be quite high. So for that purpose, I mean, yeah, like this is already this, because of that, the vertical irregularities comes in, leading to very high seismic, unwanted seismic demand. Now, effect of, again, plan and vertical irregularities considering 2025 and 2016 versions. Earlier there was the clause 7.1 and 4 and 5 for the plan and vertical irregularities respectively. The provisions are now split into the general part 1 and the new ISO 93 part 5 2025. So there are two codes now. So the entire provisions of the vertical and the horizontal irregularities are now given in two different part 1 and part 5. So this, please read your part 1 with in conjunction with your part 5 to get the complete picture, to obtain the complete picture of such changes or such revisions. Now coming to the identifications criteria. We know it, torsions, mass, stiffness, geometric irregularities, that was already there, and we considered, like, for a specific percentage threshold, we are considering 1.5 times of the displacement of the torsions we are considering. But the definitions, though, I mean, it's kept same, but it is clarified and made it more clear and more robust, especially when to consider soft story and the weak story, and in case of setback buildings I just talked about the vertical irregularities in the previous slides. Some mandatory analysis is now introduced. Earlier, for the irregular buildings, it is recommended for the response spectrum analysis, and it was simply kept that sometimes analysis may be performed, or it was kept some kind of, or kind of a this time, this one, like, time was kind of optional. So optional nahi, but should be performed, but there's no clarity as such on that matter. But now this, response system method has been strengthened, providing specific suits of ground motions, far field ground motions ke liye kuch aur near, for the near fault ground motions is something. So this, just note that for the zone 4 and zone 5 and zone 6, these are mostly like near fault ground motions, because the fault line is not far from that place, from the site. So in that case, it is very specific now for zone, for all zones it is made or for fall field, but for zone and zone 5 it is near fault earthquake. So ground motions to consider for the torsional, or to consider the vertical or horizontal irregularities. Now this, torsional irregularity. So earlier it was 1.5 times, it was kept. Now this, now the more participation factors can meet the specific threshold requirements, which is 65% for the first three. More emphasis is given on the floor rotations. This is very important and very, this will capture the entire phenomena as the more accurate measures in the research, as I told you already, suggesting a tighter control on the seismic response, on, like, it is not a training sessions which will only focus on the training part on the design. The theme also suggests that it is a it is a FDP program on the codal interpretation and the research direction. That's why it's just emphasizing on that torsional irregularity considering rotations of floor. So it needs some kind of researcher's mind as well to understand and to add something new to it or give my own interpretations. So yeah, I need to look into that matter in detail later on. Soft story and weak story. Yeah, this is it. Required specific design force is given some emphasis. It was often cited as 2.5 times of the force of the soft story. It was earlier a thumb rule kind of thing, but now those provisions are made more straightforward and more mandatory. So it is no more such things. No. These things. क्या बोलते हैं? Just what he said, like no. Uh, Vague things or one size fit for all kind of solutions is introduced. This provisions are more stringent now, likely requiring eliminations of the weak story configurations or very detailed explicit design procedures to handle the discontinuity in stiffness and strength. Next up, we have vertical load offsets. So this outer plane offsets were already there, identified as the plan irregularities, and out irregularities. The new codal provisions has giving some clear guidelines on handling discontinuous in the vertical elements, ensuring continuous load path are maintained. Earlier, I mean just of course, like in any standard design software, were incorporating that. So this probably that is something which was not mentioned but still being followed by the designer. But this is now more explicit. Coming to the mass participation factor change, so amendment number 2 of these 2016 versions, which came later actually after the publication of the code, 2018 or 2019 probably sometime before the lockdown, I hope. So this, I mean, they talk about they introduce the specific checks of the lateral irregularity based on whether the first three modes achieve 65% of the mass participation, irrespective of the zones, whether it's but no, but the lower zone and the other zones, like higher zones, zone 2 and zone 3 has some different same rules, and zone 4 and zone 5 has some different rules. Okay, out of the zone 3, 2, 3, 4, 5. Now, these mode for sector are kept as central to determining if the building can use simpler analysis methods or require more complex modeling across all new zones. Yeah, in case of in the newer versions, it was made a bit more simplified, which you would be happy to see with. In fact, the practicing engineer will be happy to see with, because now in this case, it has been made more generalized, the mass participation factor for the first three modes. It is no more a zone specific one. So for zone 2 to 6, so in these 5 zones, it is made simple and uniform. Now, this non-structural components, as I told you, non-structural components, there is no such things. There was some figure and it was left as it is without any further description or the analysis. But in these things, the major focus was given on this, on that part of the non-structural components. Let it be a facade, false ceiling, heavy masonry, or some other installations to the main building. If those are heavier than the 1% of the other installations or the floor total floor load, then obviously you need to consider this in your analysis, and you have to anchor them with it. And why this is so? Because in case of a hospital building, or let's say school building, or in a very research laboratory, non-structural components cost more than the building. Like a build a just since you come from different engineering colleges, so you know that there are some heavy expensive installations in yours, and some sensitive equipments. We deal with some sensitive equipments, but the department like chemistry, chemical, and other electronics, they're using crores of equipments, and but not without any anchorage. If there is any lateral vibrations, they will roll on the floor, and due to pounding effect, this can be uh, uh, this can cause more damage to the structure and to more damage to itself. At the same time, this I mean, the monetary loss will be even more, because it's not only the building, the heavy and the expensive equipments or installations in the building itself got damaged. So yeah, this is one concerns which has been carefully addressed. So yeah, now this coming to the closer. So I yeah, just what is actually it is saying, it is giving some risk informed analysis requirements. The uniform approach, one size fit for all, approach is now minimized. I would not say it's not there, but it's minimized. Hardly will find any specific equations for any, any equations which will be applicable for each or every zone. Okay, so zone based rigor is maintained, mandating the dynamic analysis based on the seismic zone severity, including the newly added zone of course, the highest point, zone 6. Holistic safety of structural and non-structural components are considered. I just talked about. So I am at the end of the lecture. This is the very last slide. And the sharper and unambiguous definitions. Like, earlier things were, kind of left to the designer to an extent. Time history analysis, sorry, analysis may be performed. Now, these are now very clear, very stringent, very stricter. This has to be done. There is no ambiguous statement that has been used in the recently revised code. The code is thrice more enriched than its immediate earlier version. And again, thank to Dr. Rajaram and the administration of his university that they could come up with such a topic, and that on the very second or third week of the introduction of the codal provisions. Yeah, this posed some hardships towards its resource persons like us. That's where the code was in the draft mode and nobody was considering. But suddenly it is into existence, and to prepare ourselves, we need to go through everything as much as possible. Of course, that's and to come up with some new informations to you guys. I'm happy that to be invited or to be a part of this faculty development program. I must acknowledge the invitations of Dr. Rajaram and the administration, the HOD of the civil engineering department there. That is it. That is from